Welcome back to Daily Dose of Space. Space is often described as violent. Stars explode, black holes tear matter apart, galaxies collide, radiation floods the universe from every direction. When we think about space, we usually imagine chaos on scales so large that human intuition completely fails. But there is another side to the universe, a side defined not by explosions, but by silence, by emptiness, by temperatures so low that even the faint background glow of the universe itself becomes a source of heat. Today, we are going to a place that challenges one of the most basic assumptions we have about reality. A place colder than the space between galaxies, colder than the cosmic background radiation that fills the universe. This is the story of the quietest place ever observed. Why absolute zero should be impossible. To understand why this place is so strange, we need to talk about temperature itself. Temperature is not just about how hot or cold something feels. It is a measure of motion. On a microscopic level, it tells us how much atoms and molecules are moving, vibrating, and interacting with one another. Absolute zero represents the theoretical point where this motion reaches its minimum. It is defined as 0 Kelvin, or minus 273.15 degrees Celsius. According to classical physics, nothing can go below this temperature. In practice, reaching absolute zero is impossible. There is always some residual motion, some interaction with the environment, some form of energy that prevents matter from becoming perfectly still. Even space is not truly cold. The universe is filled with the cosmic microwave background, a faint glow left over from the Big Bang. This background radiation has a temperature of about 2.7 Kelvin. No matter where you go in the universe, this radiation is always there, gently warming everything it touches. Or at least, that's what we believed. Space is not empty and not quiet. It's easy to imagine space as a perfect vacuum, a place of total emptiness where nothing happens. But reality is far more complicated. Interstellar space contains gas, dust, radiation, magnetic fields, and particles moving at extreme energies. Even in the emptiest regions between galaxies, the universe is still alive with subtle activity. On top of that, space is constantly bathed in energy from stars, quasars, and cosmic rays. Absolute quiet, in a physical sense, should not exist. Which makes the following discovery so unsettling. Astronomers found a region of space where matter is not only isolated, but actively shielded from nearly all sources of energy. A place where temperatures drop below the cosmic background itself. A place that should not be colder than the universe. The Boomerang Nebula. The object is called the Boomerang Nebula. It lies about 5,000 light-years away from Earth, in the constellation Centaurus. At first glance, it looks unremarkable. A small, faint nebula surrounding a dying star. But appearances are misleading. The Boomerang Nebula is formed by a star that is in the final stages of its life. As it sheds its outer layers, it ejects gas at incredible speeds, creating a rapidly expanding cloud. This expansion is the key. As the gas rushes outward, it cools dramatically, much like air escaping from a compressed container. The faster the expansion, the greater the cooling effect. In the Boomerang Nebula, this process is extreme. Measurements show that parts of the nebula have temperatures as low as 1 Kelvin. That is colder than the cosmic microwave background, colder than the natural temperature of space itself. As far as we know, this makes it the coldest naturally occurring place in the entire universe. How this is even possible. At first, astronomers didn't believe the data. A temperature below the cosmic background radiation implies that the nebula is somehow insulated from the universe, that it is expanding so rapidly and so efficiently that it effectively cools itself faster than background radiation can warm it. Further observations confirmed this interpretation. The Boomerang Nebula is losing mass at an extraordinary rate. Gas is being expelled at speeds of up to hundreds of kilometers per second, creating an expanding shell that acts like a cosmic refrigerator. What makes this even stranger is how brief this phase is. This level of extreme cooling only lasts for a short time on astronomical scales, perhaps a few thousand years. A blink of an eye compared to the lifetime of a star. We are observing the Boomerang Nebula at an incredibly special moment, before the expansion slows, before the nebula warms back up, before it becomes just another ordinary planetary nebula. In other words, we are watching a temporary violation of our expectations about cosmic temperature. What quiet really means in the universe. Calling this the quietest place is not just poetic language. At such low temperatures, molecular motion is severely limited. Chemical reactions slow to a crawl. Radiation is minimal. Energy exchange is suppressed. In many ways, this environment is closer to stillness than anything else we know in nature. And yet, this quiet is not permanent. The Boomerang Nebula is still evolving. Its central star will eventually heat up, ionize the surrounding gas, and transform the nebula into something far more energetic and luminous. The quietest place in the universe exists only because of violence that happened earlier. The rapid loss of stellar mass, the instability of a dying star. Silence, in this case, is a temporary consequence of chaos. Why this matters. It's tempting to treat this as a cosmic curiosity, an extreme record holder with little relevance to the rest of astrophysics. But the Boomerang Nebula teaches us something important. It shows us that the universe can produce conditions far outside what we consider normal, simply by following basic physical laws under extreme circumstances. No exotic physics is required, no violations of thermodynamics, just expansion, energy loss, and timing. It also reminds us that our intuition often fails when scales become large enough. Even something as fundamental as temperature behaves differently when applied to objects thousands of light years away. And finally, it highlights how lucky we are, because if we had looked too early or too late, we would have missed this entirely. The quietest place in the universe is not a void. It is not empty space between galaxies. It is a dying star, caught in a brief and fragile moment where expansion outruns heat itself. And the unsettling question is not how cold this place is, but how many other extreme states exist, hidden in plain sight, waiting for us to notice them for the first time.